Good day, everybody. I hope you're all fine. So, today we'll be doing an interesting topic physical sciences paper on physics, vertical projectile motion, VPM. Okay, so welcome back to my channel. Please do not forget to subscribe, like, and share. So, now let's start. VPM, it is what you call vertical projectile motion. Now, we'll be talking about it called descriptions of projectile motion, and now discussing examples of projectiles and each and everything. What am I talking about? I'm simply talking about the things of like throwing a ball upwards or dropping a ball downwards, etc. The motion in the air, okay? The motion of objects in the air, the motion of objects moving on the air, okay? Because you all know that another thing is that we know that the earth pulls and all objects towards with the what downward gravitational force, okay? So at the same time we'll be also discussing what you call the gravitational force, which is equals to 9.8 meters per square seconds, okay? So now here are the first two important terms that you have to know under VPM. They are the definitions which are always there. The first one, it is what? Free fall. Okay, so free fall, it is the motion under which the only force acting is the what? Force of gravity. Okay, so now that you just have to know that it is what? The motion under which the only force acting is the force of gravity. Okay, that is what you have to know. These are the definitions which are being asked. And then projectile, this is the what? This is an object which has been given an initial velocity. After that, it moves under the influence of the what? The gravitational force. Okay, they are nearly the same thing, but just that this one has been given an initial velocity. This one, it is just in a motion under which the only force acting is the what? Force of gravity. So now these are the only two definitions which are being asked under this question. This is question 3 on your paper, grade 12. So now another thing is that you have to understand the acceleration due to gravity and another things, but you do not have to stress about those ones. So now in this video we'll be discussing examples of projectiles: a rock, ball, or bullet. And then now and things that are being dropped or things that are being thrown upwards. Okay, so we'll be discussing those type of things. So now the first example, we can have a person standing somewhere up there. This is a person here, and then that person simply drops that thing. That thing will also will do what? Simply go down, because that person dropped that object or that ball. Number B, will be discussing something like a person is standing here, and then that person throws that certain ball, and then it goes upwards and then comes down here. But in this topic, we do not say, we usually say that projected upwards. It has been taken upwards with a certain velocity, because here on the first one it was just being dropped, meaning that the initial velocity is what? 0 meters per second. But you're gonna go to our equations of motion. Now it is just introduction. And then now the second one, as you can see, this guy is standing here, so he gave this ball an initial velocity because he simply projected it upwards with a certain velocity. Okay, that's how it is. So now the number C, it is when a person is also standing there, but what is that person doing? He is throwing that ball or projecting that ball downwards. Check, this one was just standing and then he dropped it, so there was no initial velocity. He did not project it downwards with a force or with a certain velocity. But this one now, he's also standing, but he did what? He gave this ball an initial velocity and threw it downwards, projected it downwards. Then number D, we can have a person again doing what? Throwing a ball upwards, then it comes downwards. Okay, so now those are the type of things that you're gonna be doing. Okay, so now let's continue. Now let's just continue and do some of the few things. If you are requested to describe the motion of a projectile for a given time interval, then the first thing first, you can indicate the object's initial velocity. Initial velocity is vi, and the object's what? Final velocity, which is vf. Okay, that's how it is over the relevant time interval. Then number 2, where applicable, the object's initial and final position or displacements must be indicated. What am I talking about here on number 2? I'm simply talking about what? This one, displacement of position. It can be delta x or delta y. This is for a horizontal motion. This is for a vertical motion. Number 3, you can do what? Mention that it is always subject to a gravitational acceleration downwards, because you know that this is what? 9.8 meters per square meters. So now when you are still there, remember that a projectile falls freely at a constant gravitational acceleration of 9.8 meters per square seconds downwards, okay? Even if the object moves up after it has been projected upwards. So even if it is going upwards, it is always under what you call the constant gravitational acceleration downwards. And then now the velocity of the object changes in magnitude and direction during its free fall motion, but not in acceleration. Another thing you have to note is that the velocity of its at its maximum height or the turning point is 0. So let me just do an illustration here. So as you can see here, what I was talking about, I was saying that the velocity of each and every object at its maximum height here, you do math. So this is the same as our turning point. At this point, the velocity, it is equals to 0 meters per second, because it is at its maximum height. So it has been projected upwards, and then when it is here, that is when the velocity is equals to 0. Okay. Another thing is that the time which is upwards during the turning point is also equal to the time from the turning point to the initial. The time upwards to the turning point is equal to the time from the turning point to the initial starting position. What do I mean by that? The time for the ball the time that the ball took from this point up to that one, it is the same time that it took from this point up to this one, and this is referred as to what? Time symmetry. And then now, the speed at which an object leaves your hand is the same speed at which it returns. You understand? If your hand remains in the same position. So if you stand here and then you throw a ball upwards, the very same speed that, or the very same velocity that you projected the ball upward with, it is the very same one when it comes down here, if you're going to be on the same position. Okay. And then now, the displacement of an object is the shortest vertical distance between its final and initial velocity, initial position. So now let's go through this small diagram. So now this is the initial velocity, where where it is projected vertical upwards. So this is where it is starting. It is initial velocity. And then now, as the ball is going upwards, it loses its speed, like the velocity upwards decreases. So here, velocity decreases, because you know that when you're throwing a ball upwards, as it is going upward, it is losing its speed, and now that is when it is gonna fall. And then now when it is coming back downwards, that is when the velocity increases. Now it is now coming down with a faster rate, but now it goes up. But as it is going upwards, it is now losing power, and then now that's when it is gonna reach a certain height, and then at a certain height it will decrease, and then as it is going downwards, that's where it has a velocity. So now here it is the final velocity when it is now downwards. So the final velocity is equals to the negative initial velocity, because I told you that the final velocity has the same magnitude as the initial velocity, but in its opposite direction. So in this diagram, this is where it is starting. You are projecting the ball upwards. So now as it is going upwards, it is losing power. So now that is where it is going to reach its maximum height. And you know that at its maximum height, that's when the velocity is equals to 0, because it is there up there. But when it is now coming backwards, when it is now coming downwards, that's why the velocity is gonna increase. Okay. And then here it is the final velocity. And remember that I said the final velocity has the same magnitude as the initial velocity, but in the opposite direction. Because if here it is 5 meters per second, this one will be negative 5 meters per second. Okay. So now let's continue and go to what we call the equations of motion. I hope you understood that thing. So now we are simply gonna undergo and then do another thing. So now this one we are gonna do equations of motion. So now in equations of motion, this is what you're going to have. The equations of motion here are there. Okay. So now we know that a vertical projectile has an initial upward or downward velocity and moves in a straight line with a constant acceleration. We can make use of these equations of motion to calculate the position, velocity, and what you call the displacement at a given time. So now let's go. The plus and minus signs can be used to describe the motion in the opposite directions. So for example, if you say upwards, you will say plus, downwards, you will say minus. Now let's go to the what you call equations of motion. I'm gonna give you vertical motion and what horizontal motion, because it is about what you call the displacement. Okay, let's go now. We have v, it is equals to vi plus a delta t. Okay, that is the same thing as the what horizontal motion, so we are gonna stop there. Now it is the same thing on the side. So this vf, it is the final velocity, vi, it is the initial velocity, a, it is the acceleration, gravitational acceleration, which is equals to -8, which is equals to 9.8 meters per square seconds downward. It is what? A constant. It doesn't change. And then the t, it is delta t, it is what? The change in time. It is the time, okay? Which is measured in seconds. Now, the second one that you're going to do, we're going to do what you call, this one, it is vf squared equals to vi squared plus 2a delta y. Remember I said this one is what? Vertical motion. But on the horizontal motion, we don't have delta y, but we have what? Delta x. It is the same equation, but now the difference is when it comes to the displacement. Is it fine, guys? Now this one is final velocity, initial velocity, same thing, but this one is the displacement. The next one, it will be delta y equals to vi delta t plus half a delta t squared. And then on the horizontal one, you know that it is what? Delta x, this one. So now the next one that you can use, it is delta y equals to open bracket vi plus vf over 2 times what? Delta t, which is time. That's how it is. So vi and vf, initial velocity, final velocity, they are measured in meters per second. Is it fine? And then now on the second one, we have what you call a, which is what? Acceleration. Now it is measured in meters per square second. And then now the next one, it is what? Gravitational acceleration, which is g. So now it is just the same thing as that one. So now what do we have here? We have delta t, which is what? The time. The time is measured in seconds. The next one, or the last one, it is the two difference, no, the displacement, vertical displacement, horizontal displacement. So it is measured in meters. That's how it is with the equations of motion, guys. Is it fine? I hope you are still enjoying. So let's continue with our session. So now let's go to representation of 3 different types of projectile motion. Now we are going to go to 3 different types of projectile motion. Let's start with the first one, guys. So now the first one, it is what? Vertical downward projection. So now let's continue and discuss this one. So now this one, it is vertical downward projection from a starting point above the ground. So now it can be that one of that person, which I was saying that that person is standing above a something. So now this one, let's start. I said it can be dropped. So now the object can be dropped or be thrown downwards. So now it is 2 things. The object can be either dropped or thrown downwards. Is it fine? So now what do I mean? When the object it is dropped, it simply means that the initial velocity is equals to 0 because it has been thrown downwards. So it was just like this. You see, I left that thing, so it went downwards. So I didn't give it any initial velocity. So it was just dropped. Or the second one, or thrown downwards or projected downwards with a certain velocity, meaning that the initial velocity, it is greater than 0, because it is just like, say, I am leaving it and it is going where? Downwards, guys. Is it fine? That's how it is. So now that's how it is. So meaning that on the first one, we are gonna take a what you call on the first one, it is what? A downward motion. So it is simply going downwards. So the final velocity is gonna be positive. The initial velocity can be 0 or positive, and then the displacement positive, and the acceleration, you know that it is 9,8 downwards. It doesn't change. So now let's continue the second one. The second one, it is what? Vertically upward projection. So this one, it is what? Vertically upward projection from a starting point above the ground. So even this one, it is what? Above the ground. And then now the object turns and then moves downwards from the starting position. This one is interesting. But now this one, it is going to pass the starting position. What am I talking about? So let's say the person is standing here. Then that person projects the ball down upwards, and then that ball passes the point of projection and then arrives at on the ground. Because check, this is the point of projection, but it passed that point of projection and went, oh sorry, I'm not talking about the second one or the last one. So it is vertically upward projection from the starting point of an object and returns to the starting point. So a person can be standing here, throws an object upwards, and then it goes up and then comes here on him or her. So as you can see, we know that the final velocity, it is what? Equals to 0. Okay, so now this object has been given an initial velocity, like that force, so that it can go upwards there. Is it fine, guys? Yes, that's how it is with the vertical upwards, because for an object to go upward, you have to give it a force or any initial velocity so that it can go there and come back. Okay, so now that it can be like this. Okay, here and here, this can be the turning point. We know that here the what you call the velocity is equals to 0. Okay, so now that's how it is. We can go to the last one, the one I was talking about. So this one is what? Vertical upward position from a starting position above the ground, and then the object turns and then move downwards from and passes the starting point to the ground. So now I don't have the space to write that, but I hope you heard me. So a person can be standing here, then that person do what? Projects a ball upwards, and then that ball goes up and then passes the point of projection. As you can see, it has passed it here. So now that is what I was talking about now. So now we know that the time from here to here, it is the same as the time from here to here. That is how it is. Okay, so those are the main things that I wanted to tell you. And another thing, know that the starting point can be taken as the reference point, which is equals to 0. So if it is like that, the displacement below the starting point will have the same sign as the downward motion. So a displacement above the starting position will have the same sign. Okay, so that is the information that I remember right now, and then I wanted to tell you now. Okay, now I want to consolidate. So let me tell you something. The application for solving the what you call the for solving the problems using the equations of motion. Read the problem carefully and draw a sketch with all the necessary information. Okay, is it fine, guys? And then determine which part of the motion, specifically the one that the question is asking. And then with the full motion or only the upward motion, you can do what you call check, and then check the what you call the turning point if it is there. Choose the direction of motion if the working is for both an upward motion, for both downwards and upward position motion, because sometimes you can choose what, okay, I can take vertical, I can take positive as downward as positive or upwards as negative, and then yeah, that's how it is. Do not forget that when the object is dropped or it falls from rest, the initial velocity is 0. Is it fine? That's how it is, guys. And then the velocity at the turning point is equals to 0. The velocity at which the point falls increases during downwards free fall. Then the velocity at which it hits the ground, it is equals to 0, but it has a maximum value. That's all it is with VPM. We are gonna do questions and other things. Oh, and on the next video we'll be doing what you call the graphs of motion, whereby you see how it is. Yeah, then that's all it is. I hope you enjoyed, guys. Please do not forget to subscribe. Thank you very much.